So what I want to talk today, as you just heard, is another aspect of longevity. Rather than talk about actual outcomes that Doug was showing, I'm going to talk about individuals' expectations regarding life expectancy. Specifically, what individuals think are their chances of living to a given age. And here I'm going to focus on age 75. How they update those expectations with things like disability that Doug mentioned, the arrival of new information in general, and a bit how well they predict actual longevity. The next slide, please. So a lot of this alludes to what we just heard about. When individuals are making financial decisions about their life and going forward, they're going to depend a lot, whether they realize it or not, on what they think their life expectancy is. So deciding at which age to retire, for example, how much to save, how much to consume, or specific things like claiming Social Security. Do you claim at 62? Do you claim at 65, 67? Whether or not purchasing annuities makes sense or purchasing life insurance. All these depend on the individual's perception of how long he's going to live. And sort of getting this wrong can actually be very costly. If people underestimate how long they'll live, they'll spend down sort of too quickly or claim Social Security too early, and this may lead to higher rates of poverty in old age as they've outlived any assets or have too low Social Security or pensions. Overestimates, on the other hand, can lead to a loss in utility from underconsumption. They die with a large amount of wealth, which they may get some utility from leaving to their children, but mostly it's sort of wasted. They didn't get to consume those resources. Next slide, please. So as Doug had mentioned, I'm using the same survey. I'm using data from this original cohort of the Health and Retirement Study. These folks were 51 to 61 when they were first interviewed in 1992, and they've been interviewed every other year, and it's still going on. So by 2016, they were between the ages of 75 and 85 roughly. Exceptionally long panel, and we get to see lots of things unfold in these individuals' lives as they go through the end of their working lives and move into retirement age. Now, the study asked people a number of very interesting questions about what they think their likelihood of surviving is. They ask about the probability of living to 75 or 85 or approximately 10 more years, depending on their age. And the exact question is along the lines of using any number from 0 to 10, where 0 is absolutely no chance and 10 equals absolute certainty. What do you think are the chances you will live to be 75 or more? And later in the survey, they changed that scale to be 0 to 100 to sort of correspond a little better with what we think of as probabilities. And I'm going to use that 75 question because if you notice, by the most recent data in 2016, every individual in the original cohort has reached age 75. So I can look to see how accurate they were in predicting their life expectancy or predicting the probability of living to age 75. There's been some earlier work done on this, some by me and by several other people, and we basically have seen that these subjective probability estimates correspond with known risk factors. Smokers predict the lower probability of living to 75 than non-smokers. Women predict higher probabilities than men. Those who are physically active predict higher probabilities. So they sort of seem to make sense on average. There have, however, been some concerns about some statistical aspects of the data. Probably most prominently is this idea of focal responses. When people are asked the probability from 0 to 10, a lot of people report 0, a lot of people report 5, and a lot of people report 10, or scaling up to the 0 to 100, it's 0, 50, or 100. And there's been some concern on whether people understand probabilities, given that we know if you've taken a statistics course, you can't report a 0 probability or 100 chance. And even that 50-50 may just indicate that people don't really want to think about the question or have no idea. I'm less concerned about these focal responses than some other people, and I'll show you some data why in just a second. As I mentioned, the nice thing about doing this paper now is I can actually observe mortality by age 75. So how did those subjective expectations correlate with outcomes? And I see their health status over time in every one of those, every other year, whether or not their parents have died between surveys, a spouse has died, a sibling has died. So all sorts of events that might affect what they predict their probability of surviving would be. Next slide, please. So this just shows a little histogram of how many people report each probability. And you can see the big spikes at 50% in particular and 100%, and a smaller spike at 0. So there is some of this heaping at those sort of round numbers or focal responses. You also see a spike at 80, which are people who are sort of 75% chance or so. So next slide, please. What this graph does is the height of the graph shows the percent of people who reported that subjective survival probability who actually lived to age 75. So if you look at that 0 bar on the very left, about 48% of people who gave us a 0 chance that they would live to 75 actually did survive to age 75. And if you look across the table with the chart, you actually see a fairly monotonic increase. People are sort of getting this right. People who report a higher probability of living to age 75, greater fraction of them do survive to age 75. And going back to this idea of focal point, you look at that middle probability, people who reported a 50% chance, it actually seems right in line. It's a little higher fraction of those folks live to age 75 than those who reported 40%, and a lower fraction than those who reported 60%. So it doesn't look like those data are that bad. They sort of fit in. Even if you look at these endpoints, people who reported a 0 probability or a 100% probability, those are things that, as statisticians, we shouldn't like. But the 0 probability, very few or relatively few of them lived to 75. It's a little greater than those who put 10% or gave 10% as an answer, but it's not that out of line. And similarly, at the top end, people who reported 100% chance that they were going to live to age 75, it's less than 90, but otherwise it's still relatively high. So I don't think we should dismiss these people who gave these sort of round responses. And I also want to go back to that question and just highlight in the introduction to the question, people were told where 0 is no chance and 10 in the first wave is absolute certainty. So they're given that 0 and 10 in some sense are right answers. So we can't criticize them too much for predicting those. And it does seem to correspond with actual outcomes. Next slide, please. So this slide shows the actual probability of surviving and individual subjective probabilities along with the life table values. So the dark blue is the actual probability, what fraction of people survived to age 75 for women or for men. You see women have a higher likelihood of surviving to age 75. The medium blue bars are what a life table would predict. So the life table is almost spot on with the actual probability. Life tables should report averages, and they do. And then the subjective probability are the light blue bars. And you can see for the all category on the left, on average, individuals are underestimating their survival probability. But if you break this down by gender, you see that men are really spot on. It matches the life table probabilities, and it's the women who are underestimating. So I want to make 2 points here. One is very interesting. After these life tables, this is done in 1992 data when people first reported. And in 2004, Social Security Administration actually changed their life tables to increase the probability for men and decrease that for women to bring them more in line with actual outcomes. And it sort of looks like our respondents were ahead of the actuaries at Social Security in women reported too low relative to the life tables, and men were a tiny bit higher than the life table. The second issue I want to highlight is women seem to underpredict their survival probabilities, even with this later Social Security adjustment. And we do know that women have much higher rates of poverty in old age than do men. And this could be one of the reasons they're not accurately estimating how long they were going to live and not planning for a long enough life. Next slide, please. So what I look at here is when new information comes to people. So when people change their subjective reports of their health status between waves. So look at one wave down the left-hand column. They can report excellent, very good, good, fair, or poor health. And then in the next wave, they can also report excellent, good, very good, good, fair, or poor health. And looking at the bottom triangle, those are people for whom their subjective health measure improved. So they may have said good in one wave and then excellent in the other. And you see in every single one of those cells, the subjective survival probability has gone up. So people who reported good in one wave and very good in the next had an increase of 2.22 in their probability of living to age 75. Conversely, if you look at the top triangle, those are people whose subjective health decreased between waves. And in all but one of those cells, you see a decline in their reported survival probability. So people are changing these survival probabilities as their feeling about their health changes over time. And looking at down that diagonal, you'll see that people who stayed in the same health status had a somewhat decline in their survival probabilities, but those are all fairly small. Next slide, please. So what's really interesting here in this slide is the survey also asks people, has a doctor ever told you you had a heart attack, a stroke, been diagnosed with cancer, those sorts of things? So this isn't their subjective opinion of their health like the prior table. This is, did they actually experience health event or have some condition diagnosed? And a couple aspects here. If you look at those who had the condition versus those who did not, in the before columns, other than high blood pressure, for which they're almost the same, the probability of surviving to age 75 is much lower, even before the condition was diagnosed. So people who had a stroke, had diabetes, were already forecasting a lower chance of surviving. They were probably already in worse health in other respects. And then looking before the condition and after the onset of the condition, you see a decline for those for whom the condition was relevant. And you see very stable responses for those without the condition in the rightmost pair of columns. And the boldface and the red boxes indicate that the change in the reported subjective survival probability for those who had the condition and those who did not, the before and after, or first wave, second wave, is significantly different for those who had it and those who did not. So people are taking this new information about their health into account and revising their probability of surviving. And you see that holds for all conditions except high blood pressure or arthritis, which we don't think would really have that high change on your life expectancy. They can be moderated or so forth. The bottom panel shows deaths of family members. So a parent died, a mother or father, sibling died, a spouse died, and they also looked at in-laws and siblings-in-law. And none of those have significant differences in the change between waves. So it doesn't seem that the death of a parent or spouse actually changes what you think your survival probabilities are. Now, this could just be that parents of these respondents are already in their 80s. So having a parent die in their 80s may not affect what you think of your chances of living to age 75 are. Next slide, please. So what this table shows, these are the subjective probabilities versus life table probabilities over time. So if you look at wave one, individuals had an average of 68% of living to age 75. As we saw in the earlier chart, the life table value is 68.4, so they're very close. Then if you look by survivors and decedents, you see much higher probabilities for survivors than decedents. And the life table values are pretty much the same. So it does look like individuals have some additional information. If you look at the decedent values, the subjective values, they sort of decline over time, but for the survivors, they stay relatively stable. Next slide, please. And so what this slide shows is this correlation between how well do subjective survival's probabilities predict compared to life table values. And I do it just for people who survive for at least 6 waves. And you see that the correlation for the subjective measure is somewhat higher than the life table value. So people are providing more information that is in that life table that doesn't account for things like smoking status, obesity, things like that. Next slide, please. And so just to conclude, I think what we've seen here is individuals really do seem to understand their mortality risk on average. Their subjective assessment correlates well with known risk factors as well as with eventual outcomes. There's some evidence that women underestimate their survival probabilities. And again, that brings us back to maybe some concern about poverty at older ages, and that's something I'm investigating now. They also seem to update assessments with new information, the arrival of a health diagnosis, change in old health. And I want to point out that even as dramatic as those changes were, they may not represent new information for everybody. Somebody who was overweight and smoked and had a heart attack might not be surprised. So the heart attack might not convey that much new information, and yet we still see a change in the survival probability. And finally, these subjective expectations seem to have information beyond what is known from life tables. There are greater correlation, and if you run regressions with the subjective, the life table probabilities side by side, both have predictive power. So thank you.